Today we're going over 4.4, which is the laws of logarithms. Now, since logarithms are exponents, the laws of exponents give rise to the laws of logarithms. So there's different things to remember about these laws. Let A be the positive number with A cannot equal 1. Let A, B, and C be any real numbers with A greater than 0 and B greater than 0. So you have different logarithm rules, and you can use them vice versa. So what does that mean? We have log A of A times B. You guys can separate them into log A and then plus log base of A, B. Now the key is they have to have the same base right here. So this has to be the same in order for you to be able to separate them or put them together. You also have, that is the logarithm of a product of numbers is the sum of the logarithm of the numbers. Now you have the second one, which is division. Again, same base or same log. If it's division, we can subtract. These are the same rules as exponents. When you're multiplying the same base, you add the exponents. When you're dividing with the same base, you're subtracting the exponents. And then you have the third one, which is when you have log A and then A to the C power. All that does is brings the C to the front. So you have a multiplication in the front times log subscript A of A. So that is the power of a power. Remember, for the exponent rules, when you have the same base and let's say we're squaring it and then we're cubing it, you multiply those to get A of 6. The same rules of the exponents are the same rules for the logarithm. So you don't have to learn new rules, you just have to learn how to apply them. I'll write the other two. So we have A times A being the same exponent. We can add them together. Let's say this is 2 and 3. This would be A5. And if you have, let's say, division of the same base, you would subtract them to get A to the 1 power or just A by itself. So we're going to be using the laws of logarithms to evaluate the expression. So we have log 4(2) plus log 4(32). We have log 2 of 80 minus log 2 of 5. And then negative 1/3 log 2. Let's make it a 2 of 8 to be able to solve it. Now for the first one, since we're adding, let me write it down the bottom. So since we're adding right here, we're going to actually end up multiplying. So it's going to be log of 4. It's going to be 2 times 32. It's going to be log of 4. That's going to be 64. And if you guys remember the laws for logarithms that you saw in Algebra 2, the way you would do it is whatever the base is to whatever power is going to equal 64. That is an awful looking question mark. Let me redo it. So 4 to what power equals 64? And you would get that the question mark would be 3. So your answer here would be 3. For B, we have log 2 of 80 minus log 2 of 5. Because we are subtracting, this is going to be a division. So it's going to be log 2 of 80 divided by 5. It's going to be log 2 of 16. And again, it's going to be 2 to what power equals 16. So our solution would be 4. And then for the last one, we have negative 1/3 log 2 to the 8 power. Now, when you this would be the exponent of the 8. So it would be log 2 of 8 to the negative 1/3. That means we're going to flip it over. So it's going to be log 2 of 1/8 to the 1/3. Remember, a fraction is just another word for a root. So it's going to be the cube root of 8. That's going to simplify to a half. So remember, we're over 1. And then we have left with 2 to the what power equals a half. Now we know it's going to be to the negative 1 because all we have to do is flip the expression. Now, they want us to use those rules to expand logarithm expressions. So they want us to use the laws of logarithms to expand each expression. So the way we're going to do it is, notice this is being multiplied. So we're going to separate them into 2 logs of addition. So for A, it's going to be log 2 of 6 plus log 2 of x. And that would be your solution. Now, for the second one, it's a mixture of addition because we're being multiply them. And we have the exponents that we're going to have to bring to the front into each of the logs that we're going to use. So for B, it's going to be 3 in the front, and then log 5 of x, and then plus, we're going to bring the 6 to the front, 6 log 5 of y. Now, if you want to take it into 2 steps, you can and separate the logs first and then bring to the front the exponent. But if you're able to do it in just one, you are more than welcome to do so. Now for C, we have a couple things. We have a multiplication here, so it means we have to add. But the general gist is this is going to be a division, so we're going to have to subtract those exponents. So for C, I'm going to take it a few steps at a time. I'm going to write ln of AB. I'm going to separate the division first, minus ln of the cube root of C. Now remember, a root, whether it's a cube, a square, to the 4th, 5th, doesn't matter, it's still going to be a power. I'm going to write that down. And then now I am going to change this into addition. Now I'm going to change the root into a power as well, so we're going to get ln of A plus ln of B minus ln of C to the 1/3 power. Now, with the rules of the powers, we can grab that 1/3 and bring it to the front. So we're going to end up with ln of A plus ln of B minus 1/3 ln of C. Then we would get our 3 answers. I'm going to highlight them in yellow, all 3 of them. Now, example 3, combining logarithm expressions. They want us to use the laws of logs to combine each expression into a single logarithm. Now, we're going to use what we did going forward. We're going to use going backwards. So we're going to grab this 3, and we're going to put it into the exponent. Same with this half. We're going to put it up there. It's the first thing we're going to do. So for A, it's going to become log x to the 3rd power plus log x plus 1 to the half power. A fraction is always going to be a radical. So I'm going to change that into a radical. So log x to the 3rd plus log root of x plus 1. Now we have an addition, so this means we're going to multiply. So we're going to end up with log x cubed root x plus 1. And that would be your solution. You don't have to put it in parentheses. I just did in the completed notes. I have it written down like this. Either one is correct. Now for B, again, first thing we're going to do is we're going to move all those forwards multiplications into a exponent. So that 3 that have in the -4. So for B, I'm going to do it up here. It's going to be ln of s to the 3rd plus ln of t to the half minus ln t squared plus 1 to the 4th power. Now guys, remember I do my s's in cursive just because when I do math myself, my s's and my 5 look very much alike. If you can't have a difference because you're able to just differentiate them, great. But if not, just so you know, that is how I do my s's, just because I confuse them with my 5s. Now, after doing that, I'm going to change the ones that are radicals, which just happens to be the only one right here, which is a half. So I'm going to say ln of s to the 3rd plus ln square root of t minus ln t squared plus 1 to the 4th power. Now, first thing I'm going to do is go from left to right. I'm going to multiply this addition. So it's going to be ln of s to the 3rd root t minus ln t squared plus 1 to the fourth. Now this subtraction means division. So we're going to go ahead and write them as a divided. So ln equals s cubed root t over t squared plus 1 to the fourth power. Now you can either put them in parentheses or you can leave them like this, whichever is fine. I'll leave them the way they are on the computed notes. Now we're going to use the change of base formula. So this proves the following formula. So change of base formula is log b of x equals log a of x divided by log a of b. So in particular, if we put x is equal to a, then log of a equals 1, and this formula becomes log b of a equals 1 over log a of b. Now don't stress too much on the setup of the words. I'm going to go ahead and do a couple examples, and then if you have questions, let me know. So they want us to evaluate this logarithm with the change of base formula. Now this is going to be useful because not all the calculators you're able to put in the correct subscript. At least for my calculator, I'm not able to change it. Now depending on your calculator, you might. So it's important to know how to do it no matter what calculator you might have. So use a change of base formula and common or natural logarithms to evaluate each logarithm rounded to the 5 decimal place. So for a is log 8 of 5. So the formula is going to just be log 5 over log 8. So you're going to use the number for the top and the subscript for the bottom. To be able to plug this into your calculator by plugging in log 5 and then hit divide and hit log 8. So this is going to be 0.7739760032. Now they said to the 5th decimal place, so it's going to be 1, 2, 3, 4, 5. Right here to the 7th. Because the number to the right is bigger than 5, we're going to round up. So our solution is going to be 0.77398. Okay, so for B we have log 920. So it's going to be log 20 over log 9. So you do log 20 divided by log 9. So after you plug that into the calculator, it's going to spit out 1.363416514. We're on into the 5th decimal place. So we're going to round up to that 1. The 6 is bigger than 5, so we're going to round up. We're going to be left with 1.36342 as your final answer. If there's no questions, guys, your homework is on Canvas already and is on WebAssign already. Your homework is a total of 14 problems. It's just practicing how to use the change of base formula for about 3 of them. And then the remainder are using the first couple formulas to practice expanding and solving different logs, depending whether you have an X or you have actual numbers. But that's it for today's notes.